This video introduces QSAnglyzer, or QSAnglyzer in short. QSAnglyzer is a visual analytics tool for analyzing evaluations of question answering systems. A question answering system, or QS system, consists of multiple solvers which individually can answer questions. And a QA evaluation refers to a solver's responses to a set of questions. QA researchers experiment with different solvers and different settings of a solver, and then analyze evaluation to seek for ways for further improvement. We use QSAnglyzer for facilitating the analysis process. Here is the interface of the tool. The tool consists of three main panels: the top left evaluations panel, the top right question space angles panel, and the bottom question table panel. In the evaluations panel, users can load evaluations and end to analyze. Once an evaluation is loaded, a green vertical bar shows up to represent the evaluation. The color of the bar's bottom part indicates the overall accuracy of this evaluation. The darker green, the more accurate the evaluation is. The height represents the number of questions the evaluation contains. When users filter to a subset of questions, a partial bar shows up, and its color will reflect the accuracy of the evaluation among the subset of questions. The top right question space angle is a panel for performing what we call prismatic analysis. There are two key parts of prismatic analysis of QA evaluations. First, it groups questions into categories from multiple angles. Therefore, each angle is a different way of categorization. Second, it has a set of aggregate metrics to summarize every category. In QA evaluations, these metrics are accuracy, number of questions, and accuracy variance across evaluations. Note that the accuracy metrics may have multiple measurements, where each of them corresponds to an evaluation. In the design of this panel, each box represents an angle, and each horizontal slice is a category. The height of a category indicates the number of questions among this category. Therefore, the height of each individual box represents the total number of visible questions. Each vertical segment within a category represents an evaluation. The color of the segment corresponds to evaluation's accuracy in this category. In addition, the order of the category is based on accuracy variance, where the highest variance one goes to the top. When users hover over to a category, a tooltip will show up and display the detailed information. For example, in this current view, we have loaded 3 evaluations. And this topic angle has a category called Matter. And the tooltip here shows that there are 230 questions in this category, and the first evaluation is 33% correct. The second one is 55% correct, and the last one is 60% correct. Users can filter to any categories by clicking. They can also use this filter box on the top to do multiple category filtering. The bottom panel shows all additional details. By default, this panel is collapsed, and users can expand it when necessary. Each row in this table here represents a question, and the first few columns here are solvers' answers to the questions. Since these questions are multiple choices questions, the tool displays bar charts to indicate the score solver gives to these choices. Green means the evaluation has correct answer versus the orange means incorrect answers. Users can also retrieve further details by clicking this button here. Next, we would like to give you a real use case demo to see the gain and loss of accuracy in detail. In this case, QA researchers load evaluation from 2 versions of a solver. The left one is the older version, and the right one is a newer version. The QA researchers want to know how differently the 2 versions perform. Therefore, they first investigate this difference angle. This angle categorizes questions based on whether the questions have disagreed answers across evaluations. So they first filter to this different angle. Then they investigate this is correct angle. This angle categorizes questions based on the permutations of correctness. For example, this F/T category includes questions that the older version gets incorrect and the new version gets correct, whereas this T/F is the opposite. The X here means that the solver even produced no answers. By comparing the height of these categories, the QA researchers conclude that the newer version has a significant gain and loss in accuracy, and a lot of the gain comes from this category here, where the old version cannot even design an answer.